before I forget. This is very important, guys. Steps for solving a trig equation. Good evening. Why are you guys so late? Mr. Brown, he's literally right here. Steps for solving a trig equation. Let's highlight that, please. There we go. Thank you. If you come in late, then you need to come in quietly. Thank you. All right, guys, let's just go through those steps. It's very important. You are always going to apply those steps in the same order. If you mix them up, you're going to lose marks. You're going to get stuff wrong. Please take my word on it. So first, you are going to determine the correct quadrants. Right, how did we do that in the first one? We looked at sign must be a positive value. So then we said in which quadrants is sign positive? In quadrants 1 and 2. That's what I mean by determine the correct quadrants. Okay, we are going to do more examples now, then you'll see. If it was sign x equals negative a half, then we would say where is sign negative in quadrants 3 and 4? Okay, so that's the first step. Step 2, calculate the reference angle. Now we are going to discuss what happens when your value is negative, but I think you should remember from when we did the angle of inclination. Does that ring a bell? Remember angle of inclination in analytical geometry, it was tan theta is equal to the gradient of a line, right? And if the gradient was negative, we disregarded that negative when we found our reference angle. We just took shift tan of the positive value. Okay, that's what we're going to do here as well. So just add there. Ignore if you have space. Sorry, it's a bit. Ignore minus. Okay, we are going to look at some examples, but when you're finding the reference angle, you always ignore the minus. Then for number 3, we're going to determine the general solution using the quadrants and the reference angle. Right, the general solution is what we did up here. That is the plus 360n, plus 360n thing. All right, so that's step 3. Once you have your reference angle and you know which quadrant you're going to work in, you will find the general solutions. Now we've only worked in quadrant 1, where it is just the acute angle. In quadrant 2, it was 180 minus the reference angle. What do you guys think we'll do in quadrant 3? How do we find an angle in quadrant 3? 180 plus. Good. Quadrant 4? 360 minus. Okay, that's what we're going to do when we're working in those quadrants. So quadrant 1 is your reference angle. Quadrant 2, we can add it here. Number 3, let's add it underneath that block. Quadrant 1 is the reference angle, so I'll just say RA. For quadrant 2, you're going to do 180 minus your reference angle. For quadrant 3, you're going to do 180 plus the reference angle. And for quadrant 4, we're going to do 360 minus the reference angle. And you guys know that already. Okay, we've practiced it a lot with reduction formula. So we are using those same formulas basically to find angles that will be in the 4 quadrants. So that is step 3. All right, if the question just said find the general solution or just solve for x, then that is where you stop. In number 4, then step 4 is only if it's like this question here, where they're now saying x must be between 2 specific values. All right, that would be the 4th step. If boundaries are given, so a specific domain has been given, all right, your x values must lie between 2 specific values. Determine the actual values of x within those boundaries. That's what we did here. All right. And like I said yesterday, you don't have to write this down. You can if you want to, but it will take a lot of time. And we know that time usually is an issue in maths. So I would suggest that you do these on your calculator. All right. You don't get marks for writing this down. You literally, if it was this question, You would get a mark for 30 and a mark for 150. That's it. Okay, sometimes you might even get 1 mark for both of them. All right, so please don't spend time on writing this down. Okay, let's turn the page. Let's do number 3 together. Determine the values of x for which cos x is equal to -1/3. Now, guys, I did put the graphs there for you just so that we can check whether our answers are actually showing up on the graphs at the right spots. But you won't have the graphs in a test or exam. Okay, you need to be able to do these questions if it's just given like that. Now, guys, did they give us specific boundaries for x? No. So we are just going to do the general solution and then we stop. Okay, let's write that on the side. No boundaries. But guys, like I said yesterday, even if they are giving you boundaries, you still have to do the general solution first. Then you use your general solution to get your specific values. Okay, so you're always going to have to do a general solution. Does that make sense? Just sometimes you're going to have to do an extra step and find specific x values. Now, guys, in this case, we're working with cos. So on the calculator, we're going to have to do shift cos. But do we notice now that this is a negative value? So we need to find x values where cos of those angles, those x values, those angles, will be equal to a negative number. In which quadrants will cos be negative? 2 and 3. So we're going to work in quadrants 2 and 3. Sorry, I nearly made a plus there. So I'm just doing a very small little Cartesian plane there, and I'm putting a minus and a minus. Okay, quadrant 2 and quadrant 3. That's where cos is negative. First step done. All right, we know which quadrants we're going to work in. Underneath here, I'm going to write reference angle. You are allowed to write RA like that. Okay, you don't have to write out reference angle. To get your reference angle, we're going to do shift cos, and this is now what I was talking about earlier, just like when we did the angle of inclination, we are going to ignore that minus, because what are we looking for, guys? We're looking for that acute angle that will be in the triangle. All right, so it doesn't matter whether it's positive or negative, so we just work with the positive one. So shift cos of a third, oh, sorry, what's happening here? Shift cos of a third, and our reference angle is 70.53. We keep this in the calculator, okay? We know that we must only round off at the end. Do we know that though? That's a good question. 70.53 degrees, but it's actually this whole thing. All right, you can store it in the calculator if you want to. Second step done. Now we need to work in quadrant 2 and quadrant 3 and set up our reference angles. Okay, so we're going to say quadrant 2. You don't have to write 2, but I always do. I find it just helps to keep track of what I'm busy with. So the angle here is x equals, what do we do in quadrant 2? How do I find an angle in the second quadrant? By saying 180 minus the reference angle. Good. So 180 minus 70.53 degrees. Immediately, guys, you have to write plus 360n. Yes. So you can write the rounded value down, but you can't work with it. So it's fine if you write that down, but we're going to have to store that in the calculator, yes. Because we're going to have to use it in quadrant 2 and then in quadrant 3. Yes, you can. Yeah, that's perfect. Okay, guys, so the question that Fatima is asking is, can you not just say here 180 minus this instead of 70.53? And yes, you can, and then just type it in straight. All right, so instead of actually calculating your reference angle first and then using it and then having to worry about rounding all the time, you can do it like this. 180 minus, like that. Okay, that's fine. You can do it like that. Okay, since I did calculate it, I'm just going to store it quickly, guys. Do we remember how to store things on the calculator? Shift, store, A. All right. Now I can clear it and I can use it anytime. All right, so we need to just calculate this. 180 minus alpha A is equal to 109.47 degrees plus 360 in. And obviously, if you type that into the calculator, you'll get the same thing. That's very, very important. And I actually did leave it out here. The first time we write our n thing, we need to write n element of integers, please. Just add it into that first line. I don't have enough space here now, which is one right hand there. Okay, as soon as you introduce n, you need to tell the marker what n actually represents. And remember, n will have to be positive or negative whole numbers. Okay, that's our first general solution done, our quadrant 2 one. We still have to do one for quadrant 3. So we're going to say Q3, x is equal to, and how do we find an angle in the third quadrant? We're going to say 180 plus the reference angle. So I'm going to write 70.53, but you can write cos to the -1/3. Now guys, I'm using n again, but I already said what n represents, so you don't have to write n element of z every time, okay? You just write it once. It's like your special triangles, basically. Once you have them there, you don't have to write them again. Okay, now we're going to say 180 plus a, and we get 250. I suppose I should have been able to do that in my head, but anyway. 0.53 plus 360. And that's it. That's the end. That's our final answer. Just to recap, guys, we now have like 2 formulas that will give us specific x values, right? But since they didn't tell us that x must lie between 2 specific numbers, we have to include all of the different values. Remember, the Trig graphs will carry on forever and forever, so we have to show that in our formula. If we just look at these graphs here, this is obviously the cos graph. And then this one here at the bottom is -1/3, y equals -1/3. So we can see just in this domain that's drawn here, which is -450 to +450, there are 4 solutions, right? The first solution that we can see here is this one, 109.47. And I will get this one if I say 360 times 0, right? Remember, that's what we did first yesterday. The second one that I have here is 250. You can see that's 270. So this is the one at 250 degrees. And you'll get that specific value if you make n equal to 0 in this one. Okay, in order to get these ones, this one looks like it's like -100 and something. -109, right? You'll get that by making n, oh, lovely. By making n equal to -1 in this formula. And that one you'll get by making n equal to -1 in that formula. We don't have to do that because they didn't ask for specific solutions. Okay, I'm just showing you on the graph. You will be able to get those values. Okay, any questions on this, guys? Number 4. Oh, I forgot to mention, why did I say plus 360 in here? That's the period of the cos graph. All right, so that point will come along every 360 degrees. Good. Now in number 4, we're working with a tan graph. What is the period of a tan graph, guys? 180. Okay, now you will come to love the tan ones because this one is actually going to be much less work. The first thing that we do need to do here, though, is we need to just have tan x on its own. That too, I need to move to the other side. All right, it's like when you're solving for x, you want to get the x term on its own in a normal equation, right? Just want to get x on its own, so we're going to move that 2 over. So this is actually going to become tan x equals 1/2. Okay, so you must just check that that is actually done first, that you just have your trig ratio equal to a number. Okay, so tan must be positive. Where is tan positive, guys? In which quadrant? 1 and 3. Good. Oh, that's a wonky Cartesian plane there. So quadrants 1 and 3. Okay, step 1 done. Step 2, we need to find our reference angle. Okay, so the reference angle is going to be tan to the -1 over half, which we will store again. So shift tan over half, 26.57, if I just write down a rounded value for that. Okay, shift, store, and I'm just going to save it as A again. Okay, it's just going to overwrite my previous A value. How do I get an angle in the first quadrant? It's just the reference angle, right? So quadrant 1, x is equal to the reference angle, which is 26.57, plus 180n. Let's just write n element of z again. I know we have written it on this page before, but if this was the first trig graph question, you would have to write it there. Okay, that's actually our answer. We're actually not going to do a third quadrant solution. I wonder if anyone can figure out why. Yes. Kind of, yes, it will give you the same. So you're on the right track. I'm just looking for different words, but yes, Robin. So again, you're very close. Okay, guys, I want us to think. Okay, David, do you want to try? You guys are all kind of linking up. Yeah, you're all on the right track. I want us to think, guys, how am I going to get my third quadrant solution? What am I going to have to do? What am I going to have to write down for my third quadrant solution? 180 plus 26.57. But am I not going to get that already if I put in a 1 for n over here? Right? What will that be? If n is equal to 1 here, x will be 26.57 plus 180 times 1. But my quadrant 3 solution is going to be 180 plus 26.57. Isn't that the exact same thing? And guys, that will only happen with tan because the period of tan is 180. So if we have my 26.57 degrees here, and I add 180 degrees to get to my quadrant 3 solution, it's going to give me the exact same value. All right? So for tan, you can actually, I always do it like that. You can actually cross out your bottom 2 quadrants. The third quadrant solution is already a part of our first quadrant solution. Because if I have 26.57 and I just add 180, right, I can get that from this equation already. Okay, I don't know if that makes sense. Let's look at the graph. 26.57 is here. If I say n equals 1, I'm going to add 180 degrees to it. It's there. But this will be my quadrant 3 solution as well. Okay, so we don't have to double up on work, guys. We can literally just write a quadrant 1 solution and that's it. Okay, so for tan, let's make a little note. Only do a quadrant 1 or quadrant 2 solution. I'm sorry, I said it now as if I was going to say more, but that's actually the end of the sentence. Okay, so for tan, you're only going to do a quadrant 1 solution if it's positive, quadrant 2 solution if it's negative. You don't have to even think about quadrant 3 and 4 because it will give you the same exact answer. Right, you'll get the same answers using your quadrant 1 general solution. So that's why I say tan is actually the nicest one because you just have to do one general solution. Now guys, the thing is, if you forget that, right, if you do a quadrant 3 solution as well, you won't lose any marks. Okay, so if you forget in a test or exam, oh, for tan, I only have to do the one, and you actually do both, you won't lose any marks for doing that. It will obviously just take more time. Okay, so you can do a quadrant 3 solution if you're confused by the whole concept, but you don't have to. All right, I gave you that small little exercise yesterday. I want you to do some of those for homework for tomorrow. So let me just check where is that. Okay, it looks like this. Ignore what I've circled here, guys. This is from a previous year. I want you to do number 1, number 2, and then I want you to do number 6. I'm going to help you with number 6 now because it looks much more complicated than it actually is. In numbers 1 and 2, you're going to have to get tan x and sin x on their own first. All right, so first in number 1, you're going to move the -3 over, then you're going to move the 5 over. Okay, in number 2, you're going to move the 1 over to that side, then you're going to divide by 3. Okay, so in 1 and 2, in both of those, you first have to shift everything to the other side before you do your quadrant and then your reference angle. Just hold on. In number 6, there's a lot of stuff happening here, hey? Just quickly do me a favor, type sin 17 into the calculator. Sin 17. What is that? It's a number, is what I'm trying to get at, right? Sin 17 is a number. What about cos 71? It's also a number. So what you're going to do here, you're going to say cos x is equal to sin 17 minus cos 71. I'm going to type that into the calculator and it's going to give you a number. All right, let's check quickly what that number is. Sine, I know you said some of them already. Sine 17 minus cos 71. That is negative 0,03. Now, obviously, you're going to have to use this exact number, the unrounded value, when you're finding your reference angle. But this is going to give you cos x equals negative 0,03. And we can do that, right? Cos must be a negative number. Where is cos negative? In quadrants 2 and 3. Okay? So it looks very hectic because there are multiple causes and there's a sign as well. But those are actually just numbers. Okay, so you're going to treat them as numbers. Right, so you're going to do 1, 2, and 6 for tomorrow, please. Are there any questions on this work before we hand out the tests? Fine, okay.